Okay, this is going to be a supplemental exercise for linear programming. So I'm going to give you a real quick basis. This is probably something you have not seen before. I know some of the other stuff in the algebra section you've probably seen. Linear programming is probably brand new. So hopefully by now you've started 7.5 and you're looking at some of them. But when we do linear programming, there's three things we got to have. The first thing is an objective function. Okay, this is the objective. This is the point of what we're trying to do. Usually this is going to be a maximum or a minimum. Okay. Then the second thing is going to be some constraints. Okay, if we're trying to maximize something, there's probably some constraints. Usually time or money, those are both constraints. So we're going to have those. And then the third thing is really going to be this graph of inequalities. Okay, which was from section 7.4. So hopefully you got that. And we're going to start looking at these graphs of inequalities here in a minute. But these are the three things we have to solve these linear programming problems. Part of the problem you guys are going to have is that these are mostly all word problems. Okay, so I'm going to go through and kind of try to break down how we would set these things up. Okay, so print out this week 6 linear programming supplemental exercise, and we're going to start going through that. Okay, all right. So we're going to go through 3 problems. Actually, I'm going to go through 2 of them. The last one I'm going to leave for you. Okay. So this first one is a story about mining. A mining company operates 2 mines, mine A and mine B. Operating mine A for an hour requires 25 man-hours and the pumping of 200 gallons of water. Operating mine B for an hour requires 15 hours of labor and the pumping of 300 gallons of water. Okay. This week, the mining company has 15 man-hours of labor available and is permitted to pump 21,000 gallons of water. Okay. So those are both restraints. Okay. We only have 15 hours of labor and we can only pump 21,000 gallons of water. So those would be constraints later on in this problem. Okay. If the profit from operating mine A for 1 hour is 500 and from mine B is 600, how much should each mine operate each week in order to maximize their profit? So that's our objective right there. It's usually in this last sentence. Okay. In this case, we want to maximize the profit. So I think it makes sense to let variable A be the number of hours that mine A will operate this week. And then we'll let B be the number of hours that mine B will work. You can use any variables you want. If you want to switch them to X and Y, that's fine. Okay. All right. The objective function is the total profit. So write expressions for the amount of profit from mine A. Okay. Well, mine A makes $500 per hour. A is the number of hours. So my profit from mine A is just going to be 500A. The profit from mine B, it makes $600 per hour. So that's going to be 600B. Okay, so the total profit from the 2 mines in terms of A and B is going to be 500A plus 600B. This is my objective function. Okay. All right, one of the constraints on production is the number of man-hours. Okay, it's the number of hours. We talked about that. It's 1,500 hours per week. Okay, so mine A requires what? We'll go back up. Mine A requires 25 hours of labor. So that's going to be 25A. 25 hours, okay, per week. To operate mine B, it's requires 15 man-hours of labor. So this is 15B. Okay, how many total man-hours are available? That was the 1500. Okay. So we know that 25A plus 15B has to be less than or equal to 1500. This is a constraint. Okay. The other constraint is the amount of water. We can't pump forever. We can only pump 21,000 gallons. And mine A requires 200 gallons per hour. And mine B is 300 gallons. And we can only pump 21,000 gallons. Okay. So my other constraint is going to be 200A plus 300B has to be less than or equal to 21,000. Okay. And in most of these problems in linear programming, I'm going to say all of them, negative numbers really don't make sense. We can't pump for a negative amount of hours. So A and B, or X and Y, typically always have to be greater than or equal to 0. Okay. So these are my two constraints. Okay. One is pumping the water. The other one is man hours. And then these two, what I call generic ones. Okay. So hopefully that helps us set this thing up. Let's see what we're looking at now. Okay. All right. Now they skipped some steps here. If I look at my constraint from the first one, 25A plus 15B has to be less than or equal to 1500. Okay. When you're graphing these, it's going to really help you to find the intercepts. Okay. The X and Y intercepts, or in this case, the A and B intercepts. So if I let A equal 0, this becomes 25 times A. B, divide both sides by 15, I get 100. Okay. If I let B equal 0, so this becomes 0. Divide both sides by 25, so I'm going to take 1500, divide it by 25, and I get 60. Okay. So these would be my A and B intercepts. I don't really even know which ones they are yet. We'll figure that out in a minute. If I look at my other equation, the 200A plus 300B, let me make sure I'm still on the screen here. Yeah, we're good. 200A plus 300B has to be less than or equal to 21,000. Okay? So I am going to find my X and Y, or my A and B intercepts. If I let A equal 0, 200 times 0 is 0, I get 300B equals 21,000. So I'm going to take 21,000 and divide it by 300, and I get 70. Okay? If I let B equal 0, I take 21,000 divided by 200, and I get A is 105. Okay. So now I think I can go over here. Again, remember my constraints. A and B have to be greater than 0, so everything's going to be in the first quadrant. Okay. So if I look at the B axis, 0, 100, 0, 70, this is the B axis. This has to be the point 0, 70, and this is the point 0, 100, because 100 is more than 70. Okay? If I look at this, the A axis, I have a 60 and a 105. So this must be the 60, and this must be the 105. Okay? All right. So the point where the line of man hours crosses the B axis, let's see, which one was man hours? This was man hours. Correct? So the 25A, so the 0, 100, that's point B. So this is 0, 100. Okay? The point where the water constraint crosses the B axis must be the 0, 70. Okay? The point where the line of man hours crosses the A axis, that's this one, that's the 60, 0. And then the other one is 105, 0. Okay? Now, where do these two lines cross? Well, I don't know. So I'm going to come over on a blank sheet of paper. And I am going to solve this system of equations. Okay. So the way it's set up, I have the A's and B's on one side, so I'm probably going to use the addition method. And let's see, I think 25 goes into 200 8 times. So I'm going to multiply this by a -8. Okay, slide this over a little bit. So I get -200A minus 15 times 8 is 120B. 8 times 1500 is -12,000. I'm going to rewrite this second equation. And then I'm going to add these together. The A's cancel, which is what I want. 300 minus 120 is 180B equals 9,000. So solving for B, I'm going to divide both sides by 180. And I get B equals 50. Okay? So if B is 50, I can plug that back in up here. So I'm going to say 25A plus 15 times 50 equals 1,500. 15 times 50 is 750. Okay? Subtract 750 from both sides. So you can see this is really, this is 750. This linear programming is everything we've been doing in Chapter 7. Divide by 25. So 750 divided by 25 is 30. So A is 30, B is 50. So that's the point where they cross. So this point, A is 30, and B is 50. Okay? Now, they just kind of went here. Points 1 and 4 are not in a feasible region. When I'm graphing these inequalities, again, I graph one and I shade. Okay? So I would have had to have been below both of these lines. So these points here, even though they're below this line, they're not below this line. So this is my feasible region. So the only points I can use are 0, 70, 60, 0, and 30, 50. Okay? So of my answers, which is the largest? Okay? Not the biggest point. I have to go back to my objective function. Well, let me see. My objective function was the profit. And what did the profit equal? The profit equals 500A plus 600B. 500A plus 600B. So at 0.70, 500 times 0 is 0. 600 times 70 is 42,000. 500 times 60 is 30,000 at this point. And then at this point, 30, 50, A is 30 and B is 50. So 500 times 30 plus 600 times 50 gives me 45,000. Okay? So which one of those is the largest? Hopefully we can see. That 45,000 is the largest. That's my biggest profit. So my biggest profit will be $45,000. Okay? When does that happen? When A is 30 and B is 50. It's not always going to be that point of intersection, but a lot of times it will be. Okay? So in order to maximize the profit, the mining company should operate mine A for 30 hours and operate mine B for 50 hours. and their maximum profit will be $45,000. Okay? And that's one really good linear programming problem. Okay? So, now we'll take a deep breath, and we'll go to the next one. All right, and this is a story about coffee. So a coffee roaster sells 2 blends of coffee, a basic blend and a premium blend. In order to make the blends, they use a combination of Sumatran and Hawaiian coffee. To make each pound of basic blend, they use 0.5 pounds of this Sumatran and 0.75 pounds of Hawaiian coffee. To make each pound of premium, they use 0.6 of the Sumatran and 0.4 of the Hawaiian. Okay? They have 24 pounds of coffee in stock, so that's going to be a constraint. Somehow that 24 pounds is going to be a constraint because I only have 24 pounds of this. The 30 pounds of this has to be Hawaiian. Change this to Hawaiian. I'll try to change that on your sheet. And 30 pounds of the Hawaiian coffee in stock. Okay? Each pound of basic blend makes a profit of $2. Each pound of premium blend makes a profit of $3. So again, we're trying to maximize my profit. So there's my objective function in this last sentence. Okay? So I'm going to let B be the number of pounds of basic blend. Okay? Or I guess, I don't know if pounds, maybe the number of bags or whatever. Yeah, because it's 1 pound bag. Okay, and R is going to be the premium. So B is for basic, and somehow they're using R here for premium. I would use P, but I guess that's going to be profit. So premium blend. Okay, so we're using B and R as my variables. All right. So what's my objective function? Let's start with that first. The objective function was to maximize profit. So looking back at this problem, my profit for the first one was $3. No, it wasn't. It was $2. And then $3 for the premium. Okay, that's my profit on each bag of that. Okay, how much of the Sumatran do we have available? Okay, that was the first one. We said we only have 24 pounds of that. Okay, so in each 1 pound bag, in the basic, I'm using 0.25. And in the other one, in the premium, I'm using 0.6 of the Sumatran. So this is all the Sumatran. Okay, the Hawaiian coffee. We only have 30 pounds of Hawaiian. Make sure you catch that I change that if I don't get a chance to change it on your worksheet. Okay, and in the basic blend, we use a little bit more of that, 0.75, and in the premium blend, we use 0.4. Okay, so the Hawaiian must be a little bit nicer because we're using more of that. I take that back. The Sumatran must be nicer. Okay. All right. Now it says sketch the feasible region. Okay. Label the coordinates in the corners of each region. Okay. So again, let me take these constraints. I'm going to slide this over here a little bit because it looks like my. Sorry about that. It looks like maybe you couldn't see some of that. I think it moved when I wrote on top of it. Okay. All right. So profit 2B plus 3R. 0.52B plus 0.6R is less than 24. 0.75B plus 0.4R is less than 30. So I'm going to come over here and I'm going to make a table. Whoops. B and R, not X and Y. So if I let B equal 0, so 0.25 times B, that goes away. I'm going to take 24. And I know these are decimals, just use your calculator. And R has to be 40. if r is 0, 24 divided by 0.25, I get 96. So those are my b and r intercepts for this first constraint. Okay. The second constraint is 0.75b plus 0.4r has to be less than or equal to 30. So if I take 30 divided by 0.4, excuse me, keep messing this up. So this is b and this is r. If I let b equal 0, I simply get 0.4r equals 30. So 30 divided by 0.4 turns out to be 75. Okay. Let r equal 0, 30 divided by 0.75, and I end up with 40. Okay. I guess I skipped E here. Negative numbers don't make sense, so these have to be greater than or equal to 0. And again, I was just about to graph this thing and tell you that I only need to graph in the first quadrant. Okay, so let me see. I would highly recommend doing these tables first because now I know R has to go what? Up to 75. Okay, so I might go by, I don't know, I'll go by 25s. 25, 50, 75. So 0, 40 is right here. I'm graphing this first one. It looks like B goes up to 96. That's the highest. So I guess 25s will be good again. 25, 50, 75, 100. Okay. So 0, 40 is right here. And then 96, comma 0 is over here. So that's that constraint. If I were to test the point 0, 0, 0 plus 0, 0, that's less than 24. So I would definitely shade below that line. Okay. When I go to graph this second constraint, 0 and 75 is way up here. And then 40 and 0 is like right here. Okay. So this is the point 40, 0. Okay. I have to shade between lower than all of those. So again, I get this nice little trapezoid down in here. Okay. So I need to find this point of intersection. Okay. So I'm going to write this down on my scrap paper. 0.25b plus 0.6r has to be equal to 24. 0.75b plus 0.4r has to be equal to 30. Okay? So this is the system of equations that I need to solve. I know they're decimals, but hopefully we can see 0.25 goes into 0.75 3 times. So I'm going to multiply this one by -3. So -3 times 0.25 is -0.75b. 0.6 times -3 is -1.8r. 24 times -3 is -72. I'm going to add that to this equation. -0.75b plus 0.75b cancel. -1.8 plus 0.4. Again, try not to let these decimals mess you up too much. And then -72 plus 30 is -42. And most of these should work out. If you divide by -1.4, you get r equals 30. Okay, so I get a nice number out even though I got all these decimals. Okay, let's plug that back in. So I get 0.25b plus 0.6 times 30 equals 24. 0.6 times 30 is 18. So 0.25b plus 18 equals 24. Subtract 18 from both sides. 0.25b equals 6. 6 divided by 0.25 is 24. So that is my point of intersection. B comes first, and then R. Okay? So let's slide that over to my graph. We just found this was 24, 30, and it looks like it. Here's 25, so my graph isn't horrible. Here's 30, so that makes sense. All right. All right, my objective function was profit equals 2b plus 3r. So at the first point, I guess it doesn't matter. I'm just going to take 0.40. That be my first point. B is 0. 3 times 40 is 120. My next point will be, I'll just go in this direction, 2430. That's the point of intersection. So 2 times 24 plus 3 times 30 is 138. Too excited. Okay? And then the third point over here is down here on the b-axis, okay, is 40, 0. And 2 times 40 is 80 plus 0, so here the profit would only be $80. So which point gives the maximum profit? The 2430, and the maximum profit then is 138. Okay? So then answer the question. The question was, how much of each one should they make? So they need to make 24 bags of basic blend and 30 bags of premium blend to make a profit of $138. Okay? So I'm going to leave the third one for you. Again, these take a long time. Don't get too frustrated if you can't get every part of it. You know, when the time comes for a test, sometimes I'm going to give you this graph and you just have to do this part of it. Sometimes I just ask you to find the constraints and just write them out. So I don't know that, I think there's one question where you have to do all of this. Okay, so don't stress out. 7.5 I think is a very difficult section. So just take your time, do the best you can, and hopefully it goes well. All right, so that's it for this week. So you basically have one problem you got to work on. All right, good luck. I'll leave that there for a second, or I guess you could just pause, but write the constraints, do the graph, fill in each corner. Okay, good luck.